Hello everyone, I'm Pankaj Sharma and welcome back to Brainleague Learning, where concepts become clear and numericals become simple. Welcome to this rapid practice session on electrostatics for Class 11 and Class 12. We will solve 12 typical numericals, step by step, with diagrams, formulas, substitutions, and final answers. Use these to sharpen your intuition and speed. Let's begin. Problem 1. Two charges are placed along a horizontal line. Q1 is plus 2 microcoulomb and Q2 is minus 3 microcoulomb. They are 0.5 meters apart. Find the magnitude of force on Q2 and the direction. We will draw a simple line showing the two charges and the separation. We use Coulomb's law of magnitude, F equals K times the absolute value of Q1, Q2 divided by R squared. Substitute K equal 9 times 10 to the 9, Q1 equal 2 microcoulomb, Q2 equal 3 microcoulomb, R equals 0.5. The result is 0.216 Newton, and since the charges are opposite, the force on Q2 is toward Q1. Problem 2. A point charge of plus 5 microcoulomb is at the origin. Find the magnitude and direction of the electric field at x equal 0.2 meters on the positive x-axis. We mark the charge at the center and the field point to the right. The field magnitude is E equals K Q over R squared, and direction is radially outward from a positive charge. Substitute values. We get 1.125 times 10 to the 6 Newton per Coulomb directed in the positive x direction. Problem 3. Two equal positive charges of plus 3 microcoulomb are placed symmetrically. What is the electric field at the midpoint on the line joining them? We draw both charges and indicate the midpoint. Fields at the midpoint are equal in magnitude but opposite in direction, so they cancel. Therefore, the electric field at the midpoint is 0. Problem 4. A charge of minus 4 microcoulomb is at the origin. What is the electric potential at R equals 0.3 meters? We mark the charge and the point. Potential V equals KQ over R. Substitute values. We get negative 1.2 times 10 to the 5 volts. Problem 5. A charge of plus 8 microcoulomb is fixed. Move a test charge of plus 2 microcoulomb slowly from 0.2 meters to 0.5 meters from it. Find the external work done. We draw the charge and indicate initial and final positions. Work done by external equals change in potential energy equals test charge times change in potential. Compute potentials KQ over R at the two radii and subtract. The answer is negative 0.432 joule. Negative means the external agent does negative work. The field does positive work. Problem 6. Two charges are placed on the x-axis at plus and minus 0.1 meters. Q1 is plus 2 microcoulomb at negative 0.1, and Q2 is minus 1 microcoulomb at plus 0.1. Find the potential at the origin. We show both charges and the origin. Potential superposes. V equals K times Q1 over R1 plus Q2 over R2. Each distance is 0.1 meter. The net is K times 1 times 10 to the minus 5, which is 90,000 volts. Problem 7. A plus 1 microcoulomb charge is at the origin. There is a plus 4 microcoulomb at plus 0.3 meters and a plus 1 microcoulomb at minus 0.3 meters. Find the net force on the central charge. We place the three charges on a line. Compute magnitudes. F from the right is 0.4 Newton to the left. F from the left is 0.1 Newton to the right. Net is 0.3 Newton to the left. Problem 8. A parallel plate capacitor has area 0.02 square meter and plate separation 1 millimeter. Find its capacitance. Use epsilon not equals 8.85 times 10 to the minus 12. We sketch two parallel plates. Capacitance equals epsilon not A over D. Substitute and compute. The answer is 1.77 times 10 to the minus 10 farad, Coulomb 9. The same capacitor is connected to a 200-volt source. Find the stored charge and energy. We indicate the plates with a battery symbolically. Use Q equals CV and energy U equals 1/2 CB squared. Compute numerically. We get Q equals 3.54 times 10 to the minus 8 Coulomb, and U equals 3.54 microjoule. Problem 10. Capacitors 3 microfarad and 6 microfarad are connected in series across a 12-volt battery. Find the equivalent capacitance, the common charge, and the voltage across each capacitor. We draw two series capacitors connected to a battery. In series, the equivalent is product over sum. Charge is same on each. Voltages are Q over C. Compute the numbers. Equivalent is 2 microfarad. Charge is 24 microcoulomb. Voltages are 8 volt and 4 volt. Problem 11. A point charge of 5 nanocoulomb is at the center of a spherical Gaussian surface. Find the total electric flux through the surface. Use epsilon, not equal 8.85 times 10 to the minus 12. We draw a sphere with the charge at center. Gauss's law says flux equals Q enclosed divided by epsilon naught. Substitute the numbers. We get approximately 565 Newton meters squared per Coulomb. Problem 12. An electron is placed in a uniform electric field of 1000 Newton per Coulomb along the positive x direction. Find its acceleration. Use electron charge 1.6 times 10 to the minus 19 Coulomb and mass 9.11 times 10 to the minus 31 kilogram. We show a rightward field and an electron. Force equals QE and acceleration equals force over mass. Compute equals QE over m. We get magnitude 1.8 times 10 to the 14 meter per second squared, directed opposite to the field, that is along negative x. Great work! Let's display a quick recap of the 12 answers for your review. Practice these again, and try to predict each answer before it appears. With repetition, your speed and intuition will grow. See you in the next lesson.